NEC Article 300.22 current and NFPA 90.44.24 prohibit the installation of panel boards in an air handling space. This is primarily due to the potential for arcing faults or other electrical hazards to ignite combustible materials present within the air handling system. The rationale behind this prohibition is to prevent the rapid spread of fire and smoke throughout the building via the ventilation system, which could have catastrophic consequences. An air handling space is defined as any space used for the transport of environmental air, including plenums and ducts. Panelboards, being electrical devices with exposed energized components, pose an ignition risk. In the event of a fault, such as a short circuit or ground fault, a panelboard can generate intense heat and sparks, potentially igniting nearby combustible materials. The air handling system would then distribute the resulting smoke and fire to other parts of the building, endangering occupants and hindering fire suppression efforts. Consider the specific implications of installing a panelboard in a negative pressure environment, such as a return air plenum. The negative pressure within the room could exacerbate the risks associated with electrical faults. Specifically, it could draw air containing electrical arc byproducts or other contaminants into the air handling system, potentially contaminating other areas of the building and posing health hazards to occupants. Electrical equipment is not typically designed to operate in a negative pressure environment, which could shorten its lifespan or create additional safety hazards. The negative pressure could affect the cooling and ventilation of the panelboard, potentially leading to overheating and premature failure of components. Access to the panelboard for maintenance or repairs would be difficult and potentially hazardous due to the negative pressure. Personnel working on the panelboard would need to take special precautions to avoid being exposed to the negative pressure environment and any contaminants that may be present. Considering these factors, it is generally not recommended to install panelboards in a return air plenum or any other air handling space. Several alternative solutions can be considered to address the need for electrical distribution in such areas. Firstly, install the panelboard in an adjacent room or area that is not part of the air handling system. This would isolate the panelboard from the potential hazards associated with the air handling environment. Secondly, create a separate, enclosed space within the room for the panelboard, ensuring that it is properly ventilated and sealed from the air handling system. This would provide a barrier between the panelboard and the air handling environment, preventing the spread of contaminants and mitigating the risks associated with negative pressure. Thirdly, use a different type of electrical distribution system, such as a busway, that is specifically designed and listed for installation in air handling spaces. Busways are typically enclosed and fire-rated, providing a higher level of protection against fire and electrical hazards. Furthermore, consider the specific requirements of the NEC and NFPA 90 when designing and installing electrical systems in air handling spaces. These codes provide detailed guidance on the types of equipment and wiring methods that are permitted in such environments, as well as the necessary safety precautions. Article 300.22c of the NEC specifically addresses wiring methods and equipment permitted in other spaces used for environmental air. It distinguishes between different types of air handling spaces, such as ducts and plenums, and specifies the requirements for each. NFPA 90 provides additional requirements for the installation of electrical equipment in air conditioning and ventilation systems. It covers topics such as fire dampers, smoke detectors, and emergency shutdown systems. When evaluating the suitability of electrical equipment for installation in air handling spaces, it is essential to consider the following factors. Firstly, the equipment's listing and labeling. Only equipment that is specifically listed and labeled for use in air handling spaces should be installed in such environments. Secondly, the equipment's fire resistance. The equipment should be constructed of materials that are non-combustible or have a low flame spread rating. Thirdly, the equipment's ability to withstand the environmental conditions present in the air handling space, such as temperature, humidity, and air velocity. In addition to the code requirements, it is also important to consider the potential for future changes to the air handling system. If the system is modified or expanded in the future, it could affect the suitability of the electrical equipment installed in the space. It is important to ensure that any future modifications comply with all applicable codes and standards. Finally, consult with a qualified electrical engineer or other professional with expertise in electrical systems and building codes. They can provide valuable guidance on the design and installation of safe and compliant electrical systems in air handling spaces. The primary concern with installing electrical panels in return air plenums revolves around fire safety. Should an electrical fault occur within the panel, the resulting arc flash and potential fire could be rapidly spread throughout the building via the ventilation system. This is why codes like the NEC specifically restrict such installations. The specific section you mentioned, NEC Article 300.22 cone, is very clear on this point. It dictates what types of wiring methods and equipment are permitted within ducts and plenums used for environmental air. Generally, only wiring that is essential for the operation of the ventilation system itself is allowed. This typically includes wiring for smoke detectors, fire dampers, and other safety-related equipment. Panelboards, which serve as distribution points for electrical power throughout the building, are not considered essential for the operation of the ventilation system and are therefore prohibited. NFPA 90A, which is a standard for the installation of air conditioning and ventilating systems, reinforces these restrictions. It provides detailed requirements for the construction and installation of air handling systems, including limitations on the types of materials and equipment that can be located within plenums. Beyond the risk of fire spread, there are other concerns associated with installing panel boards in return air plenums. One significant issue is the potential for contamination. Air handling systems are designed to circulate air throughout the building, and any contaminants present within the plenum can be easily distributed to other areas. Electrical equipment, including panel boards, can generate dust and other particulate matter that can contaminate the airstream. In addition, electrical faults can release harmful gases and fumes into the air, posing a health hazard to occupants. Another concern is accessibility. Panelboards require regular maintenance and inspection to ensure their safe and reliable operation. Installing a panel board in a return air plenum can make it difficult to access the equipment for these purposes. Plenums are often confined spaces with limited headroom and poor lighting, making it challenging to work on electrical equipment safely. In addition, the negative pressure within the plenum can create further hazards for workers. Given these concerns, it is generally best to avoid installing panel boards in return air plenums whenever possible. There are usually alternative locations that can be used to house the equipment without compromising safety or accessibility. If it is absolutely necessary to install a panel board in or near a return air plenum, it is essential to take extra precautions to minimize the risks. This may include using a special enclosure to protect the panel board from the environment, providing additional ventilation to prevent overheating, and implementing strict procedures for maintenance and inspection. It is also important to consult with a qualified electrical engineer to ensure that the installation complies with all applicable codes and standards. When considering alternatives to installing a panel board directly in a return air plenum, several options exist. One common approach is to locate the panel board in an adjacent room or area that is not part of the air handling system. This provides a safe and accessible location for the equipment without exposing it to the hazards of the plenum. Another option is to create a separate, enclosed space within the room for the panel board. This space should be properly ventilated and sealed from the air handling system to prevent the spread of contaminants. The enclosure should also be constructed of fire-resistant materials to protect the panel board from fire. A third option is to use a different type of electrical distribution system, such as a busway. Busways are typically enclosed and fire-rated, making them suitable for installation in air handling spaces. However, it is important to ensure that the busway is specifically listed for use in such environments. Ultimately, the best approach will depend on the specific circumstances of the project. It is important to carefully consider all of the factors involved, including the size and layout of the building, the type of air handling system, and the applicable codes and standards. By taking a proactive approach to electrical safety, it is possible to protect building occupants and prevent costly damage. Electrical panel boards are crucial components of electrical distribution systems in buildings, serving as central points for dividing electrical power feeds into subsidiary circuits while providing protective fuses or circuit breakers for each circuit in a common enclosure. The National Electrical Code, or NEC, provides detailed guidelines for their installation to ensure safety and prevent electrical hazards. One critical aspect of panelboard installation is their placement relative to air handling spaces, particularly return air plenums. A return air plenum is a space used for the return of air in a heating, ventilation, and air conditioning, or HVAC system. These spaces can be above suspended ceilings, in dedicated shafts, or even entire rooms designed to handle return air. Due to the potential for fire and smoke to spread rapidly through air handling systems, the NEC places strict limitations on what can be installed within these plenums. Article 300.22 of the NEC specifically addresses wiring and equipment permitted in ducts and plenums used for environmental air. This section generally prohibits the installation of electrical equipment, including panel boards, within these spaces unless the equipment is directly related to the air handling system. The primary reason for this restriction is to prevent electrical faults from igniting combustible materials within the plenum, which could then spread fire and smoke throughout the building. Panel boards, with their exposed electrical connections and potential for arcing faults, pose a significant fire risk. If a fault were to occur within a panel board located in a return air plenum, the resulting fire could quickly spread through the air handling system, endangering occupants and causing extensive property damage. NFPA 90. The standard for the installation of air conditioning and ventilating systems provides further guidance on this issue. It outlines requirements for the construction and installation of air handling systems, including restrictions on the types of materials and equipment that can be located within plenums. NFPA 90 emphasizes the importance of preventing the spread of fire and smoke through air handling systems and highlights the potential dangers of installing combustible or hazardous materials within plenums. The specific situation described involves an entire room under negative pressure, serving as a true return air plenum. This scenario presents additional challenges and considerations. The negative pressure within the room can draw air and any contaminants present into the air handling system, potentially affecting air quality throughout the building. In addition, the negative pressure environment may not be suitable for the reliable operation of electrical equipment. Panel boards are typically designed to operate in environments with normal atmospheric pressure and temperature. Installing a panel board in a negative pressure environment could affect its cooling and ventilation, potentially leading to overheating and premature failure. Access to a panel board installed in a return air plenum can be difficult and potentially hazardous. Plenums are often confined spaces with limited access, making it challenging to perform maintenance or repairs. The negative pressure within the room could also create uncomfortable or hazardous working conditions. Given these considerations, it is generally not recommended to install panel boards in return air plenums. Alternative solutions should be explored to provide electrical distribution in the area. One option is to locate the panel board in an adjacent room or area that is not part of the air handling system. This would isolate the panel board from the potential hazards of the plenum and provide easier access for maintenance. Another option is to create a separate, enclosed space within the room for the panel board. This space should be properly ventilated and sealed from the air handling system to prevent the spread of contaminants. The enclosure should also be constructed of fire-resistant materials to protect the panel board in the event of a fire. In some cases, it may be possible to use a different type of electrical distribution system that is specifically designed for installation in air handling spaces. For example, a busway system may be suitable if it is enclosed and fire-rated. However, it is important to carefully evaluate the specific requirements of the NEC and NFPA 90 before using any alternative electrical distribution system in a return air plenum. The NEC is updated every 3 years, and it is essential to stay current with the latest requirements. Changes to the code can affect the permissibility of certain types of equipment and wiring methods in air handling spaces. In addition to the NEC and NFPA 90A, local building codes may also have specific requirements for electrical installations in air handling spaces. It is important to check with the local authorities to ensure compliance with all applicable codes and regulations. When evaluating the suitability of electrical equipment for installation in air handling spaces, it is important to consider the following factors. Firstly, the equipment's listing and labeling. Only equipment that is specifically listed and labeled for use in air handling spaces should be installed in such environments. Secondly, the equipment's fire resistance. The equipment should be constructed of materials that are non-combustible or have a low flame spread rating. Thirdly, the equipment's ability to withstand the environmental conditions present in the air handling space, such as temperature, humidity, and air velocity. To expand on possible alternative solutions when a panel board cannot be installed in a return air plenum, several approaches can be considered. Firstly, installing the panel board in an adjacent room or area offers a straightforward solution. This involves locating the panel board in a space that is not part of the air handling system, thereby avoiding the restrictions and potential hazards associated with plenum installations. The adjacent room should be readily accessible for maintenance and repairs and should provide a suitable environment for the panel board to operate reliably. Secondly, creating a separate, enclosed space for the panel board within the room is another viable option. This involves constructing an enclosure around the panel board that is sealed from the air handling system. The enclosure should be properly ventilated to prevent overheating and should be constructed of fire-resistant materials to protect the panel board in the event of a fire. Thirdly, utilizing a busway system as an alternative electrical distribution method can be considered. Busways are enclosed, prefabricated electrical distribution systems that can be suitable for installation in air handling spaces, provided they are specifically listed for such applications. Busways offer a compact and flexible solution for distributing power and can be particularly useful in situations where space is limited. Fourthly, employing remote power panels offers another alternative. Remote power panels are smaller, more compact panel boards that can be located closer to the loads they serve. By using remote power panels, the main panel board can be located outside of the return air plenum while still providing convenient power distribution to equipment within the room. Fifthly, utilizing power distribution units, or PDUs, can be considered. PDU are commonly used in data centers and other applications where reliable power distribution is critical. PDU can be mounted on racks or walls and can provide power to multiple devices. By using PDU, the main panel board can be located outside of the return air plenum while still providing power to the equipment within the room. Sixthly, implementing a combination of solutions may be the most effective approach. In some cases, a combination of the above solutions may be necessary to meet the specific needs of the application. For example, a remote power panel could be used in conjunction with a busway system to provide a flexible and reliable power distribution solution. When selecting an alternative solution, it is important to consider the following factors. Firstly, the available space. The amount of available space will influence the choice of solution. In situations where space is limited, a compact solution such as a busway system or a remote power panel may be the best option. Secondly, the electrical load. The electrical load that the panel board needs to support will also influence the choice of solution. A larger electrical load may require a more robust solution such as a busway system. Thirdly, the accessibility. The accessibility of the panel board for maintenance and repairs is also an important consideration. The panel board should be located in a place that is easy to access and work on. Fourthly, the cost. The cost of the solution is also an important consideration. The cost of the solution should be weighed against the benefits it provides. Fifthly, the code compliance. The solution must comply with all applicable codes and standards. It is important to consult with a qualified electrical engineer to ensure that the selected solution meets all code requirements. In addition to the above considerations, it is also important to document the alternative solution. The documentation should include a description of the solution, the reasons for selecting the solution, and any special considerations that were taken into account. The documentation should be kept on file for future reference. By carefully considering the various alternative solutions and documenting the selected approach, it is possible to provide safe and reliable electrical distribution without violating the restrictions on installing panel boards in return air plenums.